Hello and welcome to this video on functions and function notation. Our first example, we are looking at some relationships between x and y values, and we are determining whether they describe a function. Remember, a relation is only a function if every x corresponds to no more than one y. So every x in the domain corresponds to only one value in the y. What that means, if we're looking at a list of points like we have here on part A, we cannot have our x values repeated. So we have the point -7, 7, the point 6, 1, the point 5, 0, and the point -4, 1. So we're looking at our x values there, the -7, the 6, the -5, and the -4. If they are not repeated and we've only got one y value on each point, then it will be a function. Now notice we do have a y value that is repeated. We've got a y value that's 1 on both of them. That does not affect whether or not something is a function. And so this first one will be a function, and then we're asked to find the domain. Well, remember, the domain is all of the x values that correspond to real y values. So the only x values that we have that are corresponding to y values are going to be the set that includes -7, 6, -5, and -4. We are going to use curly brackets around those to indicate that that is a set, and that would be our domain. Since we don't have an interval here, we'll use those curly brackets to list out the items in our domain. All right, our next example, doing the same thing, we have the equation x squared minus y equals 3. One of the best ways to determine if you have an equation, you want to solve for y. And so if we solve x squared minus y equals 3, if we solve that for y, we're going to subtract x squared and divide by -1, and that gives us y equals -3 plus x squared. The reason we want to divide by y, we want to isolate that y, is to see if we get any repeated y values. So if we take any x number, doesn't matter what it is, and we square it, and we subtract 3 from it, we get a single y value. There's not more than one option there. And because every x gives us only one y, that means this one is also a function. And since we are squaring it and subtracting 3, we can take any number, square it, and subtract 3. We don't have any restrictions, so our domain is going to be from -infinity to infinity, or you could also use the symbol for all real numbers, which is called a double bar R. All right, our next example, we've got y squared equals 8 minus x. Well, y squared equals 8 minus x, we need to solve that for y. In order to get that y by itself, we need to take the square root of both sides. Remember, when we take the square root, when we introduce that square root, we've got to put a plus or minus on it, because y can be either positive or negative in this case. So we get plus or minus the square root of 8 minus x. Here, if we take an x and we plug it in, say we'll do x equals -1, that will just make this a perfect square. So if we plug in x equal -1, we do 8 minus a -1 is going to be 8 plus 1. That's going to give us 9. The square root of 9 is 3. But that's going to give us y equals plus or minus 3. That's two different numbers, a positive number and a negative number. So this one, a single x value gives us two different y values. So that means it is not a function. It's still a relation, but it is not a function. All right, the domain, remember, we can only take the square root if what's inside the square root is non-negative. So we're going to take just what's inside that square root. In this case, 8 minus x has to be greater than or equal to 0. We can't have a negative under there, so it's got to be greater than or equal to 0. That means that 8 has to be greater than or equal to x. And so our domain, if we put that in interval notation, x is going to be smaller than 8, so that means negative infinity to 8 is going to be the domain of that relation. All right, our next example, we're given the function f of x equals x over x squared plus 1, and we're asked to find the following. F of 0 is the first thing. So the notation that we have here, f open parentheses, 0 close parentheses, is read f of, in this case, the number in there, 0. And what it means to do is everywhere that we have an x in our function, we are going to replace that x with the number that we have, or whatever it is that we have inside the parentheses. So f of 0 means we're going to plug in 0 for all of our x's. So our function f of x equals x over x squared plus 1 becomes 0 over 0 squared plus 1, and that simplifies to just 0 over 1 or 0. And so we get f of 0 equals 0, and what that's telling us is that the graph of this function goes through the origin 0, 0. We get our x value and our y value on that graph. All right, we're going to do the same thing, same function. Now we're going to find f of negative 8. So we're doing the same thing that we were just doing. We're going to plug in negative 8. Now we had x squared in the denominator. We want to square this whole negative 8. So we want to put that in parentheses so we can square that whole thing. All right, simplifying that numerator gives us negative 8. Denominator is going to be negative 8, quantity squared is 64, plus 1 is 65. That fraction doesn't reduce, and so that would be our answer. And that, again, we could look at it as the graph goes through the point negative 8 over 65. All right, this next one doesn't have a number in there, but we can treat it the exact same way. We want to find f of negative x. So we're going to plug in a negative x everywhere we saw an x. So just like we did with the 8, x in the numerator now becomes a negative x. The x squared in the denominator, remember we got to put that in parentheses and square everything that's in the parentheses here. So quantity negative x, quantity squared, plus 1 is our denominator. In the numerator, we can simplify that and write that as just negative, or we're not simplifying anything in the numerator. In the denominator, we have a negative x squared. Well, a negative times a negative is going to give us a positive, and then x squared is just x squared plus 1. And so that would be our expression. We would say f of negative x is equal to negative x over x squared plus 1. And we'll do a little bit more with that in later sections. All right, our next example, we're finding f of x plus 3. Going through the exact same process that we have been doing. The x in the numerator is going to become an x plus 3. In the denominator, we want to take this whole x plus 3 and square it. So we're going to make sure and put that in parentheses. All right, don't have anything to simplify in the numerator. In the denominator, we can simplify that a little bit. We can square that out. You can either think of that as writing x plus 3, and using FOIL, multiply box, whatever method that you use to expand polynomial multiplication. Or you can remember if we have anything that's written in the form of a plus b squared, that's going to be a squared plus 2ab plus b squared. And so that's what I'm going to do. My a here is x and my b is 3. So I'm going to get x squared plus 2 times x times 3 is 6x, plus 3 squared is 9. We still have that plus 1 on the end, so don't forget about that. And then simplifying, combining like terms in the denominator, we get x squared plus 6x plus 10. And you could look and see if maybe you could factor that, but there are not factors of 10 that add to 6, so that's not going to simplify any. Don't be tempted to divide out an x plus 3 on this first step here, because remember, you cannot take anything out of a fraction. You can't divide it out of a fraction unless it comes out of all the terms. All right, our last example here is something that we will be seeing in this section as well as all the way through calculus. One of the common things that we do in calculus is evaluate function notation at f of x plus h. So we're going to do the exact same thing that we just did with that x plus 3, but now we're going to have an h instead of a 3. So we get x plus h in the numerator. Remember, we're all still plugging all of these problems. We're plugging back in. We're plugging in for the x in our original function, x over x squared plus 1. In the denominator, we get x plus h, quantity squared, plus 1. And this one, we can expand it in the denominator. It's not going to help us a whole lot. We can square this out. I'm going to use the same formula that we used on the previous one. So now our x is our a and our h is our b. So that's going to be x squared plus 2xh plus h squared plus 1. And honestly, as far as simplifying it, you can't really argue that one's more simple than the other. We can't even combine any terms here. And oftentimes you like to keep stuff factored if you can, but that would be, now we could plug in any value of h and get that without having to simplify as much as we did on the last one. All right, I'll see you guys next time.